Okay, identities. I decided to get as many identities as I could find. Some of them are dating as far back as 2012 or earlier up to 2025. Just want to show you that these things are solved the same way, and all you need these three identities here. And then you also need to know that sec is 1 over cos theta, cosec is 1 over sine theta, then cot is 1 over tan theta. In case you forget, just count to 3. 1, 2, 3, you have cos. 1, 2, 3, you have sine. And then 1, 2, 3, you have tan. And then you also need to know that tan is sine over cosine. So without wasting a lot of time, let's start with the first one, which is 2025. So I have 1 plus sine theta over cos squared theta, and then 1 minus sine theta over cos theta squared minus 2, and this is equivalent to 4 tan squared theta. So now we know that tan squared theta means sine squared theta over cos squared theta. So whatever you do, just make sure that you have cos squared theta in the denominator and sine squared theta in the numerator. So as you can see, we only have one part here, but we have three parts this side. So that means we have to combine them until we have one part. So to do that, you have to get rid of the squares first. I'll expand using the binomial theorem, or you can use the other method where you write them side by side like this. Yes. So when I square this, I'll have 1 plus 2 sine theta plus sine squared theta. And then remember, the square is for both the numerator and the denominator. So we have cos squared theta. And then plus, this one will be 1 minus 2 sine theta plus sine squared theta, then everything over cos squared theta, and then minus 2. So we have to express this as a single fraction by finding the lowest common denominator. And because the denominator here is cos squared theta as required there, you don't need to change it, just leave it as it is. So this into this, you have a 1, you multiply by that, you have the same thing. The same applies to this one. This into this, you have a 1 multiplied by that, you still have the same thing like that. And then we have a 1 there if you want. So 1 into this, you have cos squared theta multiplied by that, we have minus 2 cos squared theta. And then now we can just put the like terms together by saying 1 plus, we have another 1 there. And then next we can move on to the sine theta. So we have 2 sine theta, we have another 2 sine theta there, so these two are subtracting. And then we have sine squared, this will be sine squared theta, another sine squared theta there. And then finally we have minus 2 cos squared theta. We left out anything? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I think we are okay. And then we can add the like terms. Here this is a 2, and then that's a 0. This plus this, we have 2 sine squared theta, then minus 2 cos squared theta, everything over cos squared theta. So now to remember the direction here, we want sine squared theta to be in the numerator. So anything that is not sine has to be dealt with, but because there is nothing much you can do with these two, unless you want to multiply it by this, which is a 1, you can just change this instead. So to change this, I can just use this, and then I'll take this one to the other side so that I have cos squared theta is equal to 1 minus sine squared theta. Remember, this identity is provided on your cover page. So we have 2 plus 2 sine squared theta. I'm not going to tamper with this because it is required. So we have 1 minus sine squared theta, everything over cos squared theta. Then you have 2 plus 2 sine theta. You expand, you have that. You expand, you have 2 sine squared theta, everything over cos squared theta. And then we have the 2 minus 2, that's a 0. And then we have sine squared, 2 sine squared theta plus 2 sine squared theta. We have 4 sine squared theta over cos squared theta, which is what we need. And then because we are trying to show that this thing is equal to 4 tan squared theta, I'm not going to leave it like this. I'll say 4, then this part here is tan squared theta, and you're done. And then the next one, this is 2024 internal. I think this was easy. So we have tan theta plus cot theta, and this is equivalent to sec theta cosec theta. So now you have to bear in mind that this thing is simply 1 over cos theta being multiplied by 1 over this is sine theta. So whatever you do, just aim for this. Once again, we only have one part here and then we have two parts there. So we have to combine these two to obtain this. So I can, as you can see, we do not have a tan, we do not have a cot this side. So we have to change these two to either cosine or sine or sec or cosec. So I'll change it to sine and cosine. So this one will be sine theta over cos theta plus cot is the reciprocal of tan, so it will just be the reciprocal of this. So you have cos theta over sine theta. And then since we only have one part here, we can express this as a single fraction. So the common denominator will be cos theta sine theta. This into this, that will give you a sine. Multiplied by sine, you have sine squared theta. Yeah, this is easy. This into this, you have cos. Cos multiplied by cos, you have cos squared theta. And then as you can see, this is that famous identity from our cover page. When you add these two, you should have a 1, which is 1 over cos theta and then sine theta. So as you can see, this is what you want. So you can even separate it like this: 1 over cos theta multiplied by 1 over sine theta. And then we all know that the reciprocal of this is sec theta, and that of this is cosec theta. And so we are done. Next, we have 2024 external. So this one had a very small mistake. They wrote cos theta here instead of cot. So I corrected it, and this is how you can verify it. So this side we have sine squared theta minus 1 plus tan squared theta, then cos squared theta, everything over sine theta cos theta, and this is equivalent to cot theta. But we know that cot theta is cos theta over sine theta. So what you do here is you can just refer to the cover page for this identity. As you can see, we have 1 plus tan squared theta, which is equal to sec in the brackets there. But if you want, you can still expand. It's the same thing. So sine squared theta minus this thing is sec squared theta, as you saw from the cover page, and then everything over sine theta cos theta. So since this is the reciprocal of this, you expect the product to be a 1. Remember, sec is 1 over cos theta, and then it's being multiplied by cos squared theta. So these two will divide, or you can just cancel them out like that, so that you have cos squared theta minus, this will simply be a 1 over sine theta cos theta. So you want cos on the numerator. You already have a sine here, so don't tamper with it. Just aim to get rid of this. So what you do here is you can change the numerator so that you have a sign. So remember, from this identity, sine squared theta plus cos squared theta is equal to 1. When you take your cosine to the other side, your sine squared theta will simply be 1 minus cos squared theta. So I can replace this with this. So I have 1 minus cos squared theta, then minus 1, everything over sine theta cos theta. Then you can just remove the brackets and say 1 minus 1, that's a 0. So you remain with negative cos squared theta over sine theta cos theta. So you have two cosines here, which you can write like this, and then one can cancel out with the other, so that you have negative cot theta as required. So now we can proceed to the next one, which is 2023 internal, this one here. So I have 2 over this is cos to the 4 theta minus sine to the 4 theta plus 1, and this is equivalent to sec squared theta, which can be written as 1 over cos squared theta. So your job here is to ensure that in the denominator you have cos squared theta, but as you can see, we don't have that. So secondly, this one has been squared, then we have 4's there. So the first thing you want to do is to factorize this using the difference of two squares, because you don't want the 4's, you want the 2's. So this one will be cos squared theta minus sine squared theta multiplied by cos squared theta plus sine squared theta, and then plus 1. In case you didn't understand what I have just done here, this cos to the 4 theta is like cos squared theta, and then you square it like that. Then this is like sine squared theta squared, and then you can just apply the concept of the difference of two squares. So now this is known, this is a 1, cos squared theta plus sine squared theta will give you a 1. So in the denominator we just have this cos squared theta minus sine squared theta plus 1. And then now from here, remember, you just want a cosine in the denominator. You don't want anything else. So you have to find a way of getting rid of this. So now when you look at this, this is like 1 minus sine theta. But I'm not going to use that. Maybe I should. can just write it like so. Start with the 1 minus sine squared theta. I believe you can see that from this identity, this is actually cos. I've just taken this one to the other side. So this thing here is a cosine. So we have 2 over cos squared theta plus cos squared theta. Then you have 2 over this plus this. That will be a 2 cos squared theta. Then 2 and 2 will go, so that you have 1 over cos squared theta. And because you are showing that this is equal to sec squared theta, you can get the reciprocal of this and write sec squared theta, and you're done. And then next we have 2023. I think I meant to type external. Anyway, one of these two should be GCE. So for this one, we have 1 over sine A cos A, and then minus 1 over tan A is equivalent to tan A. Remember that tan A is sine A over cos A. So whatever you do, aim for this. Okay, we can write this as cot if you want, but if you want, you can still work it out as it is. But I think writing this as cot will be much easier. So this is cot A, and then we know that cot A is the reciprocal of tan, so that means cot A is cos A over sine A. And then now, since we only have one part here and we have two parts here, we have to express these two fractions as a single fraction. So we can do this. The common denominator here is sine A cos A. You don't need to multiply them because sine can still go into this, but it's still solvable if you decide to multiply this to accept that you increase the number of steps. So this into this, you have the 1 multiplied by 1, that's a 1. And then sine into this, you have the cosine times cosine, you have cos squared A. Now remember, you want sine in the numerator, and then you need a cosine in the denominator. So you want to get rid of this, and then you want to change this to sine. So remember, this is from this identity. When you take this one to the other side, you have sine squared theta is equal to 1 minus cos squared theta. So this will simply be sine squared A over sine A cos A. This is similar to what we were solving earlier. So you can just express this as sine A multiplied by sine A, then over sine A multiplied by cos A. And then now these two will go, and then you remain with sine A over cos A as required. But of course, you're trying to show that this is equal to tan, so you can say this is tan A, and you're done. And then next we have 2022 internal. So internal 2022, here we have this is cos theta over 1 plus sine theta, and then plus tan theta is equal to, remember sec is just 1 over cos theta. So whatever you do, aim to get cosine in the denominator. So first of all, since we have a tan there, we want to change it to sine over cosine. Remember, you want cos in the denominator and not this or this or that. So now, since we have two fractions here, you can combine them to form one. As you can see, we only have one this side. So we have 1 plus sine theta over cos theta. So do not be in a hurry to expand these two, because you want the cosine to be here. So just mess around with your numerator until you find something that will get rid of this. So this into this, you have cos, and then when you multiply by that, this will be cos squared theta. Then cos theta into this, you have this. So this will be 1 plus sine theta multiplied by sine theta. And then you can just expand that. So this times this will be sine theta. This times this will be sine squared theta. Then everything over 1 plus sine theta. Once again, leave the denominator as it is. You need the cosine. You need to get rid of this. So we can put these two together. Remember this identity. So 1 plus sine theta cos theta. So this plus this, you have the 1, and then plus sine theta, everything over 1 plus sine theta multiplied by cos theta. So as you can see, these two can be cancelled out. So this can go into these ones. So you have 1 over cos theta, which is which is simply the sec theta we are trying to find. Yeah, this one here. And then now we have 2022 GCE. So I don't know what happened this year, but this paper had a lot of challenging questions or problems. Yeah, so let's see what we can do with this. 2022 external, yeah, this one here. So we have sine theta minus cos squared theta minus 5, then everything over tan theta plus 3 sec theta, and then this is equivalent to sine theta cos theta minus 2 cos theta. So now, when you look at this, we do not have fractions here. So whatever you do, you're just trying to get rid of the fractions. So to do that, perhaps we can start by changing this into, this is a 5. We can change this to cos to sine theta over cos theta, and then minus this will be 3 over that will be cos theta. So now we can combine these two to form one. So I like putting brackets here just to minimize mistakes as much as possible. Minus 5. So the common denominator there is cos theta. Then this will be this minus that. And then when you're dividing, you can just do this. Sine theta minus cos squared theta minus 5 divided by sine theta minus 3 over cos theta. So now, when you're dividing, we normally reciprocate this. So this will be sine theta minus cos squared theta minus 5 multiplied by cos theta over sine theta minus 3. So now you can expand, but okay, I don't think it's a good idea to expand, because when you look at this, it is showing you that something was being multiplied by cos theta. So maybe you can just factor the cos theta here. Yeah, so I've just factored the cos theta out. So that means I'm multiplying cos theta by something like this. So whatever I do, I need to obtain this here, and then I need to find something which will get rid of this. So I think the only way to do that is by factorizing this. I think I solved this at one point on YouTube. So this one will be, remember we do not have any other cos here, so we want to change this one to sine. So from this identity, once again, we know that cos squared theta is 1 minus sine theta. So maybe I can use square brackets so that I can accommodate this. So this will be 1 minus sine squared theta, and then minus 5 multiplied by cos theta over sine theta minus 3. And then we can expand minus 1 plus sine squared theta minus 5 multiplied by cos theta over sine theta minus 3. And then as you can see, this is a quadratic expression, so we can just write our sine squared theta here, and then plus sine theta, this and this, we have a 6 being multiplied by cos theta over sine theta minus 3. So now I have to factorize this so that I can have an expression like this. But if you can just divide this into this. That should work just fine too. So the product here is minus 6, 1 times 6, and then the sum is a 1. We have 1 as the coefficient of sine. So that means the factors should be 3 and 2, I think, where this is a negative, yeah. So this will be sine squared theta. I'll start with minus 2 sine theta, and then plus 3 sine theta minus 6 multiplied by cos theta over sine theta minus 3. And then I can factor out sine theta here. So let me just use square brackets. So I can say sine theta out, sine theta there, we have sine theta, there we have minus 2. Then this side I can factor out a 3. So this will be sine theta minus 2, yeah, multiplied by cos theta over sine theta minus 3. And then now this part is common, so we can factor it out as well. So I have sine theta minus 2, and then when you factor this one out, you remain with sine theta. You factor this one out, you remain with plus 3. Was this supposed to be a plus? I think there was a mistake somewhere. Okay, let me just pause. Okay, figured it out. The mistake was here. So this was a plus. So it went all the way. Yeah. Yes. And then cos theta over sine theta plus 3. So now you can cancel this with this so that you remain with sine theta minus 2 multiplied by cos theta. And then now you can expand this, which will give you sine theta cos theta minus 2 cos theta, which is this thing here, which as required. So this one was a bit challenging. In fact, the entire paper was challenging. And then we have 2021. 2021, we have got theta plus tan theta, then everything over cosec theta is equivalent to sec theta. So remember, sec theta is simply 1 over cos theta. So feel free to attempt the problems or the identities before I solve, because remember, we always have different ways of proving these identities. So first of all, we have cot, we have tan, we have sec, cosec, and then what we want is cosec in the denominator. So that means you have to get rid of this. But how do you do that? You can change these to their to sine and cosine. So remember, cot is, brackets are very important here. So cot is cos theta over sine theta. Tan is sine theta over cos theta. And then this is being divided by cosec theta. So now you can combine these two by finding the common denominator. So this into this, you have cos times cos, you have cos squared theta, plus this into this, you have sine multiplied by that, you have sine squared theta, and then everything over this, which we can just write as cosec theta, like this. So this plus this will be a 1 over sine theta cos theta. And then when you're dividing, you can just change this to multiplication and say 1 over cosec theta. But of course, we know what cosec theta is. This is simply sine. Or you can still multiply this by this, and then you can say sine times cosec is 1. So I'll just change this to sine. This one is sine theta. Remember, I just want the cosine, so it's actually good that these two are cancelling out. So we're remaining with 1 over cos theta, which is sec theta, and we're done. And then the next one, this is 2021 external. This was GCE. 1 over sec theta minus tan theta squared is equal to 1 plus sine theta over 1 minus sine theta. So to prove this identity, I think it's easier to use this because there is nothing much you can do with this other than multiplying by this something known as rationalization, but I'm not going there. So to change this into this, as you can see, we only have sine here, both in the numerator and the denominator. So I'm going to change these things before I even square. In fact, I can even do this. So this one will be 1 over cos theta minus tan is sine theta over cos theta. Then we have a square like that. And then before you do anything, you can combine these two. So this one will be 1, since the denominators are the same, 1 over cos theta, and then you square it like that. And then after this, you can simply say 1 divided by this thing here, 1 minus sine theta over cos theta squared. So remember, the square is for both the numerator and the denominator. But because we do not have any square there, I don't think it's a good idea to expand this. What you can do is reciprocate it, and then maybe along the way we can figure it out. So once you reciprocate, the power will not be affected, because remember, this is squared and this is also squared. So once you reciprocate it, you don't expect the power to change. So it's good that we have this in the denominator, so do not tamper with it. Just this times this will be cos. We can expand now, but please, like I said, do not tamper with this. It is required. Remember, we have 1 minus sine squared sine theta there, not sine squared theta. So just leave it like this and then change this, because we want 1 plus sine theta in the numerator. So from the first identity, I believe by now we know that this is 1 minus sine squared theta over 1 minus sine theta squared. So now we want 1 plus sine theta here, not 1 minus sine squared theta. So what you can do here is use difference of two squares to factorize this, so that you have one part which will cancel out with one of these two, and then another part which will give you 1 plus sine theta. So this one will be 1 minus sine theta, and then 1 plus sine theta, then everything over. You can even write this in expanded form without really expanding. So this and this will go, and then you remain with 1 plus sine theta over 1 minus sine theta as required. And then next, we have we're solving, okay, we have 2020. So to prove this identity, we can say cos theta over sec theta plus tan theta is 1 minus sine theta. Okay, so in other words, you don't want fractions, you just want a sign and a 1. So how do you obtain this from this? First of all, you want to get rid of the fraction. How do you do that? Change the sec to cosine, the tan to its components. This will be 1 over cos theta, and then plus, this is sine. This is similar to what we are doing, I think. And then this is 1 over cos theta. Yeah, and then we can combine these two. Remember, the brackets here are very important, because 2 divided by 3 divided by 4 like this is not the same as 2 over 3 and then over 4. These two are different. So when you're dealing with such things, make sure you put your brackets. Then when we combine these two, the common denominator is theta. So on the numerator we should have this. And then now we can divide and say cos theta divided by 1 plus sine theta over cos theta. And then when you are dividing, remember, you can always reciprocate and change this to multiplication. 1 plus sine theta. Then you can multiply these two. So this will be cos squared theta over 1 plus sine theta. You don't want fractions. What you want is 1 minus sine theta. So maybe the first thing you want to do is to get rid of cosine using the first identity. So you just make cosine, the subject of the formula. So by now I believe you know that cos squared theta is the same as 1 minus sine squared theta, everything over 1 plus sine theta. Then you can factorize this using the difference of two squares. So this will be 1 minus sine theta over 1 plus sine theta, then everything over 1 plus sine theta. So these two can cancel out because this is what you want. So you can cancel these two out, and by so doing you would have proved the identity because this is what you want on your right hand side. Then now we can proceed to 2020 GCE. So we have 1 over sec theta minus tan theta, and then plus 1 over sec theta plus tan theta, and this is equivalent to 2 sec theta. Remember, sec theta is the same as 1 over cos theta. So since we have two parts this side, we have to combine them to form one. And how do you do that? You can change this to 1 over cos theta, this to sine theta over cos theta, but because these two are the same, I think it's better to just multiply them. Remember, the difference of two squares can give you something nice from this. So when you find the common denominator, you have sec theta minus tan theta, and then this will be sec theta plus tan theta, and then this into this is this, so this will be sec theta plus tan theta, then this into this, you have this, so this will be plus sec theta minus tan theta. I'm beginning to think it would have been easier if we had changed this to 1 over cos theta and then this to 1 over sin theta, but let's carry on and see what we obtain. So this minus this will be a 0, this plus this, you have 2 sec theta. Okay, yeah, this is what you want. So you just have to make sure you have the 1 in the denominator. So we can expand this, but as you can see, this just looks like the difference of two squares when you factorize two squares. So you can say this times this is sec squared theta, then this times this, you have sec theta tan theta. I don't even know why I'm multiplying them when I already know the answer, the product. This times this, you have minus, let me start with this so that it looks like this, sec theta tan theta, then tan theta times tan theta, we have tan squared theta, and then this will be 2 sec theta. Remember, we are trying to show that this is equal to 2 sec theta, so I don't need to change this. I should just work with on the denominator here. I was aiming for this, but luckily I have the ratio I'm looking for. So now this minus this is a 0, so in the denominator I have sec squared theta minus tan squared theta. So I can either change this to tan or this to sec. Remember this identity from the cover page. This is sec squared theta is equal to 1 plus tan squared theta. So I can just replace my sec squared with this. So this one will be 2 sec theta over 1 plus tan squared theta. Okay, I can see we are winning. And then this will be 2 sec theta. This minus this is a 0, and then you have a 1 in the denominator, which we don't normally write. And so you have proved the identity. And then next we have 2019 internal. This is 1 plus sec theta 1 minus cos theta, and this is equivalent to sine theta tan theta. So tan theta, sine theta tan theta is like sine theta over cos theta. So whatever you do, just aim for this. So maybe the first thing you want to do is to expand. So you can say 1 times this, so maybe we can change this to 1 over cosine. Yeah, it will be much easier. But if you're okay with this, you can still use it. So 1 minus cos theta. So now we can expand. 1 times this, we have the 1 times cos theta. This will be cos theta. Then this times this, we have 1 over cos theta. This times this, this will just give us a 1 because this is cos over cos. And then you can subtract these two by putting the like terms together. Let me just start with this cos theta minus cos theta. So this is this and this is this. So this minus this, we have a 0. And then for these two, remember we only have one expression here. So not really one expression, but one term. So I have to combine these two terms to form one. So I can just find the common denominator, which is this. This into this, we have the 1 times 1, that's a 1. Then this into this, we have cos theta times cos theta. This would be cos squared theta. So remember, we want sine theta and then sine over cosine. We already have the cosine in the denominator, so we just want the sine squared, or the sine times sine. Of course, we know that this is sine squared theta from the very first identity. But we want to show that this is sine squared, sine theta multiplied by tan theta. So you can write this in expanded form, multiplied by sine theta over cos theta. Of course, this is a tan, so you have sine theta tan theta, and you're done. And then we have 2019 external. So this is sine to the 4 theta sec squared theta plus sine squared theta is equivalent to this. So now tan squared theta is the same as sine squared theta over cos squared theta. So whatever you do, just aim for this. So we can start by changing this to cosine. So this is, remember, we want cos squared theta in the denominator. So this one will be 1 over cos theta, which we can write like this. And then plus, this is sine squared theta. And then we only want one expression or one term, so we can combine these two to form one. So the common denominator is cos theta. In this into this, you have 1 multiplied by that, you have this into this, we have cos squared theta multiplied by that, we have sine squared theta cos squared theta, like this. So the denominator has been satisfied. Our aim is to obtain a sign in the numerator. So how do you do that? Actually, we want a sine squared theta, so I can just factor out sine squared theta and then mess around with whatever I have in the brackets. Okay, I can see we're getting something amazing. When you factor this one out, you have this. From there, you have cos squared theta, which from the first identity, we all know that this is a 1. So you have sine squared theta over cos squared theta. And this is exactly what you are looking for, except that they want you to say tan squared theta, and you're done. And then next we have 2018 external. Okay, so we have 1 minus tan squared theta is equal to sec squared theta minus 2 tan squared theta. So this one appears easier this side than it is this side, because anyway, you can use any of the two sides. Yeah, but I think it's easier this side. Let's just use this. So of course we have an identity which relates sec to tan. So I'm not going to change this because I want it, but because we do not have a sec this side, I have to change this. And using this identity here, for sec squared theta is 1 plus tan squared theta, I can just change my sec there to 1 plus tan. Okay, this is too easy now. Yeah, this is too easy. When you subtract these two, you have your answer, and this will be tan squared theta. Okay, yeah, this is way too easy. I don't even know what it was doing in the exam. Maybe if I had used the other side. Let me just give it a try and see if it is worth it. So we want a tan, and then we also want a sec. Yeah, but I can't change this. Maybe I should just change the sign to using this identity. Sec squared theta is equal to 1 plus tan squared theta. So I can just change this one to, can take this one to the other side and say sec squared theta minus tan squared theta is 1. Yeah, so it's equally easy. So I can replace this one with this because I want a sec and I want a tan. So this will be sec squared theta minus tan squared theta, and then minus tan squared theta. So this will be sec squared theta. You subtract these two, you have minus 2 tan squared theta. This is doable either ways. If you want, you can even change this, but it's a bad idea to get rid of the tan when you know that you need it. Your aim here is to eliminate this guy. And then the next problem is 2018. This should be internal. So 2018 internal, we have sec theta cosec theta minus tan theta is equal to cot theta. It's equivalent to cot theta. So cot theta is cos theta over sine theta. So what you want to do is, since you want sine in the denominator and cosine in the numerator, and you don't need the tan, you don't need the sec, you don't need the cosec, you want to change these to sine and cosine. So this is like 1 over, this is cos theta multiplied by, this is 1 over sine theta, then minus this is sine theta over cos theta. But because we only have one term this side, you want to combine these to form one. So the common denominator is cos theta sine theta. Once again, you don't need to multiply them. If you do, it won't be a problem. You just have more work to do. This into this, you have a sine times 1. This will be sine theta. Then this into this. By the way, this is the same as this. This into this, you have a sine multiplied by sine. You have sine squared theta, like that. And then now you have the sine in the denominator. You don't want the cosine. And then in the numerator, you have actually, this is not even a sine, this is a 1. In the numerator, because this into this is 1 times 1, you have a 1. So in the numerator, you want cos. And of course, from the first identity, you can see that 1 minus sine squared theta is cos squared theta. So this one will be cos squared theta over cos theta sine theta. Then you can just write this in expanded form like so. And then now you can cancel these two out. And then you have cos over sine, which is what you want. But of course, since you're trying to show that it's a cot, you can say this is cot theta, and you're done. Then next we have we've just proved this. We have 2017. So 2017, we have sine theta over 1 plus cos theta plus 1 plus cos theta over sine theta is equivalent to cosec theta. So cosec theta is like 1 over sine theta, but because of these two, this will be 2 over sine theta. So since we only have one term here, we have to combine these two to form one, like so. So you don't have to expand this because you want sine to be the way it is right now. Once you expand it, at one point you may have to factorize it, which is a lot of work. So this into this will be sine times that. You have sine squared theta plus sine into this will be this times that. You have 1 plus cos theta, then 1 plus cos, or since this thing is the same, you can still say that. And then this will be sine squared theta. When you expand this, you have 1 plus, using the binomial theorem, this would be cos theta, or the Pascal's triangle, which tells you that you have these three factors. This would be cos squared theta, then everything over 1 plus cos theta sine theta. And then now you can just put these two together and say sine squared theta plus cos squared theta, and then plus 1, then plus 2 cos theta, everything over 1 plus cos theta sine theta. This plus this, you have a 1 plus 1 plus 2 cos theta, everything over 1 plus cos theta sine theta. So now you can add these two. This will give you a 2 cos theta over 1 plus cos theta sine theta. And then since you just want a 2 in the numerator and only a sign in the denominator, you can factor out your 2 so that this can cancel out with that. So once you factor your 2 out, you have this. Like that, and then you can cancel these 2 out, and then you have 1 over sine theta, which is basically just 2. Remember, the reciprocal of sine is cosec theta as required. And then next we have 2017 still. This is external. So this one is 1 minus cos squared theta over sec squared theta minus 1, and this is equivalent to sine squared theta, 1 minus sine squared theta. So first of all, you don't need the denominator, you just need the numerator. So what do? Of course, you can change this to tan, and then you can change this to sine and see the way forward. So let me see which one will be the easiest. Okay, so we want a sine there. We can straight away just change this to sine, since this is sine squared theta. And then this is 1 over cos squared theta minus 1. Is this a good idea? Let's try it. So for identities, you always have several ways of solving the same problem, provided you know where you are going. So we can find the common denominator here. Remember, our aim is to get rid of the denominator. So this into this, that's a 1, and then 1 into this, we have cos squared theta multiplied by that, we have that. And then after this, actually we shouldn't have changed this, so I'll change this one back to 1 minus cos squared theta, because I can see I have this thing here to divide. So this one will be 1 minus cos squared theta, and then this is being divided by 1 minus cos squared theta over cos squared theta, and this will be 1 minus cos squared theta multiplied by, I'll reciprocate this. By the way, as this is just cos squared theta, so this is another way of looking at it. You can either aim for this or this. So right now I'm aiming for this, so this one will be over cos squared theta. So this can cancel out to this, and then I'll have cos squared theta. But because we want 1 minus sine squared theta, we can change this to 1 minus sine squared theta using the first identity. This, where when you take this one to the other side. Okay, so we're done there. The next one will be R, which is 2016. So for 2016, we have 2 sine squared theta minus 1 over sine theta cos theta, which is this. So I got these questions from this PDF, which was compiled by Team High Standard. So we have this side, we have tan theta minus cot theta. Maybe it's better to use this, but we can still work with this to obtain that. I think it's easier to combine these than to separate these. So let's just change this to sine theta over cos theta, and then this is cos theta over sine theta. You can find the common denominator. This one will be cos theta sine theta Yeah, this is a good idea. It was actually a good idea to use this. So once you find the common denominator, the denominator part has been satisfied. You can just arrange it like that. Then this into this will be a sine. Then you multiply by that, you have sine squared. This into this, that will be a cosine. You multiply by that, you have cos squared. And then since we only have sine here and no cosine, so I'll change this to sine by using the first identity. So this one will be 1 minus sine squared theta. Please, because of the minus, you have to include your brackets. So I'll start with sine theta cos theta. Then when you expand the brackets, you have minus 1 and then plus sine squared theta over sine theta cos theta. Then this plus this will give you 2 sine squared theta minus 1 over sine theta cos theta. And as you can see, this is what we want. And then on we can, okay, I think we are done here. Yeah, I needed some water. We can flip the page. Yeah, so on part S we have cos theta over sec theta minus tan theta. This is equivalent to this. So now in this case, you have no choice but to start with this. Yes, you can find a way of messing around with whatever you have this side to obtain this, but you only be giving yourself extra work. So we just want 1 plus sine theta. So that means you have to get rid of the denominator. To do that, let's write this as 1 over cos theta, and then this as sine theta over cos theta, and then we can combine these two to form 1. So this, since the denominator is cos theta for both, this will just be this. Yeah, this is what we want. And then at this point, so this is actually easy, you can say cos theta divided by this thing here, 1 minus sine theta over cos theta, like this. When you're dividing, you change this to multiplication and then you reciprocate this. By the way, I thought this was a minus, so that means we still have a few more steps. So this will be cos theta multiplied by cos theta over 1 minus sine theta. So now we can multiply this by this and then say we have cos squared theta over 1 minus sine theta. So now you don't want 1 minus sine theta in the denominator. You don't want cos squared theta either in the numerator. So what you want to do is change this to sine by using the first identity. So this one is the same as cos squared theta will be equal to 1 minus sine squared theta. Yeah, so this one will be 1 minus sine squared theta over 1 minus sine theta. So now you can just apply the difference of two squares here so that you have 1. Remember, what you want is 1 plus tan theta, sine theta, and you don't have it here. But of course, you can obtain it from the sine squared. So this will be 1 minus sine theta multiplied by 1 plus sine theta, then over 1 minus sine theta. So you can cancel these two out, then you have 1 plus sine theta like this. You're done. So these two are actually dividing, but because you guys have been saying cancel out, decided to fit in. And then we have 2016. So this is sine squared theta multiplied by 1 minus tan squared theta, everything over cos squared theta minus sine squared theta, and this is equivalent to tan squared theta, which is the same as sine squared theta over cos squared theta. So now your job is to obtain this. How do you do it? Maybe we can start by changing this to, okay, we don't need sec. Okay, maybe we can just change it to sec, because remember sec square, no, it's not a good idea. Perhaps we can change okay, this, we want a sine. Okay, we already have a sine squared in the numerator, so let's leave it, and then let's just mess around with this so that it cancels out with that, and then it should give us a cosine somehow. So let's mess with the denominator. We have sine squared theta, then 1 minus tan squared theta, everything over. So I can change, anyway, let me change this. Sine squared theta 1 minus, this one will be sine squared theta over cos squared theta, everything over cos squared theta minus this. And then now at this point, I don't want to expand this, so maybe I can just do with the brackets here, combine them, and see if it will give us something that will take us to this. So the common denominator is cos. Yeah, I can see something nice coming out. So the common denominator is cos squared theta, 1 into this times that, you have cos squared theta, and then this into this, that's a 1, multiplied by that, we have this. Yeah, this is really nice because I can see that this part will cancel out with this, like that. And then at this point we can just divide by saying sine squared theta, and then cos squared theta minus sine squared theta over cos squared theta divided by this. So this is cos squared theta minus sine squared theta. I'm not going to expand here because I want my sine to be in the numerator like that. So what I'll do is I'll just change this to multiplication so that I have 1 over cos squared theta minus sine squared theta. So this one and that one will cancel out, and as you can see, I have my sine in the numerator and a cosine in the denominator, and this is tan squared theta as required. So this was a bit tricky. And then we have this one, part 2. This was 2015. This was 2015. Yeah, so we have cot squared theta, then sec squared theta is 1 plus cot squared theta. So it's easier to combine these two to obtain this than to separate these two to get that. But either ways, it should be doable. So which path am I taking? Okay, I think I'll use this. This one will be 1 plus cot. Okay, this one is wanted. Maybe we can just use this side instead. So I can change this to, remember, sec squared theta is the same as 1 plus tan squared theta. So this one will be 1 plus tan squared theta. This is actually easy, just 2 steps. And then once you expand, this will be cot squared theta. Then this times this, you have cot squared theta multiplied by tan squared theta. So we all know that these two are reciprocals of each other. So when you multiply them, you should have a 1. And you're done. So if I was to use this side, this would be cos squared theta over sine squared theta. Find the common denominator. I think it was easier this side than this side. So that's a 1. So you have sine squared theta. Then this one there, that's 1 times this, you have cot squared theta. Then when you add these two, you have a 1 over sine squared theta. And then now sine squared theta is the same as cosec squared theta. I think it was easier this side than this side. And then what can I do with cosec squared theta to obtain that? So we can just refer to our identities for cosec. So this is 1 plus cot squared theta. And now I'm going backwards. So I think it's better to use this side, because when I change this, it will take me back to the starting point. And then we have but of course you can still work backwards using this. So that means yeah, but it's a bad idea changing this to cot times tan on parts this. So here we have 2013. So in 2013 we had cos squared theta minus 1 over sec squared theta minus 1, and this is equal to negative cot theta and then cos theta. So we can use this to obtain this. Of course, we know that this is a tan, yeah, or maybe we can do this. We know that sec squared theta is 1 plus tan squared theta, so I can change this to 1 plus tan squared theta and then minus 1. This and this will subtract, so we have cos squared theta minus 1 over tan squared theta. And then since we only have one expression here, we can combine these two by finding the common denominator, which is tan squared theta, and then this into this, that's tan squared theta times that. We have cos squared theta multiplied by tan squared theta, then minus this into this, we have a 1. And then remember, this part here is like so. or maybe let me write it here. Tan is sine squared theta over cos squared theta, and then minus 1 everything over tan squared theta. So you can just cancel these two out. And then in the numerator we have sine squared theta minus 1 over tan squared theta. Since we want this, in other words, we don't want a sign in the numerator, and then we want the cot, which is what we have in the denominator, because once you reciprocate this, you have your cot. So we can just change this to cosine by using this. So sine is 1 minus cos squared theta, then minus 1, and then maybe we can just write this as 1 over tan theta, tan squared theta, so that it's easy to see that this is cot. This minus this, that's a 0, and then you have cos squared theta, and then this one will be cot squared theta, since it's tan in the denominator, and this is exactly what we are trying to prove. And then now we have 2012. I'm not even sure if it's 2012. This is why I said either 2012 or earlier. I think we proved this. Let me just check. No, we haven't. So here we have 1 over sine theta, 1 over 1 minus sine theta, and then plus 1 over 1 plus sine theta, and then minus 2, and this is equivalent to 2 tan theta, but remember tan squared theta is this. So since we only have one part here, we can combine all these three to form one. So this would be 1 minus sine theta over 1 plus sine theta. And then we only want the cosine in the denominator, so that means we have to expand this into this. We have 1 plus sine theta, and then plus this into this. This is my 1, by the way. And then this into this, we have 1 minus cos theta, 1 minus sine theta rather. And then we have the 1 there. 1 into this, it's this entire thing multiplied by 2. So this will be 1 minus sine theta, 1 plus sine theta. So whatever you do, you want a sine squared in the numerator, then you want a cosine squared in the denominator. So we can arrange these terms and expand those brackets there. So this plus this will be a 2 like terms, then this minus this, that's a 0. That's a 0. And then when you expand this, you have 1 times 1. Of course, this is just the difference of two squares. So you have 1 minus sine squared theta. And then over, when you expand this, this is also the difference of two squares. So this will give you 1 minus sine squared theta. So if you don't want to use the difference of two squares, you are free to expand like this times this one, this times this, sine this times this, sine theta, negative sine theta, and then that times that, you have negative sine squared theta. So of course, since we want we want, let me just increase the brightness. Okay, so we want the cosine in the numerator and the sign in the denominator, I'm going to change this to cosine. Remember, 1 minus cos theta is simply cos theta. So this one will be cos squared theta. And then I can expand this. Because I want the sign, I'm not going to change it to anything. I can just expand this times this. This will be minus 2 times that. We have 2 sine squared theta. Then this minus this, that's a 0. 2 sine squared theta over cos squared theta. When you divide them, this will be tan squared theta as required. So now we have the last two. So we want to show that the product of these two is 1. So to do that, maybe let me just use one of my old papers. So we can expand this by, okay, let me just write it down. 1 minus sine squared theta is equal to this. Okay, so I can either change this to a cosine, and then, or I can change this to sec. Actually, yeah, I'll change this to sec and this to cosine. This is easy. From the sec identity, you can see that 1 plus tan squared theta is sec. And then when you take sine to the other side on this, you see that what you have in here is just cosine. So I'll change this to sec squared theta. Then this will be cos squared theta. But I'm not going to just say 1 because it's too easier. So I can just change this to 1 over cos theta multiplied by this. Then I can just cancel them out, and then I have my 1. Finally, we have the last problem, where we have sine to the 4 theta minus cos to the 4 theta is equivalent to 1 minus 2 cos squared theta. Of course, we only have a square here and we have 4's there. So the first thing you want to do is to get rid of the 4's by factorizing using the difference of 2 squares. So this will be like this, and then like this. This is none, this is a 1. So you have sine squared theta minus cos squared theta. And then since you have 1 minus 2 cos squared theta, you want to get rid of the sign so that you only have the cosine. So using the first identity, we know that sine squared theta is 1 minus cos squared theta. So I can write 1 minus cos squared theta, and then minus cos squared theta. Then I can subtract these two to get 2 cos squared theta as required, and this is my answer. Well done. So proving identities is all about knowing where you are going, and then knowing how to mess around with these things. At one point, you may be required to factorize, in most cases using difference of 2 squares, in rare cases using quadratics. So the bottom line is knowing where you are going. Okay, I can end here for tonight.